camera, fraction.
Okay.
Batman.
So, you guys, we've actually talked for 2 days about exponential stuff, right? Exponents, exponential growth, and whatever. It's powerful stuff, and it's real stuff. It's real. You know, when people ask, when am I going to ever use this stuff? Well, hopefully you will be using this stuff because it will dramatically increase your financial situation if you do use it. Yes?
I have an idea for the formula. Wouldn't you do the money times the percentage, and then you do the, and then you multiply the product by how many years there are?
Mm-hmm. Sort of. So we're going to follow. So there are three equations here, right? So we have exponential growth and exponential decay. Now they look identical except for the minus sign and the plus sign. And it makes sense, really, doesn't it?
Yeah.
That growth would be a plus and decay would be a minus. Decay means, like, you know what a decaying tree is. After, you know, over the years, that tree starts to become more and more soil, right? And pretty soon, I mean, eventually, you see no tree anymore. You just see a little mound of soil, right? Right?
It's sad.
And it's sad, right? No, actually, it's good because that's giving nutrients to the thing.
Oh.
So decay does
I'm
not
happy.
necessarily mean something bad. It's actually can be something good. But let's look at this. So y is your final amount after a certain number of years, okay? So that's your y. A is your initial amount, the amount you're starting with,
$1,200.
right? So in this case, the original value of the painting is $1,200. That would be your A. That's your A. Does that make sense? A for amount, right? Original amount. Parenthesis, 1 is a 1. Isn't that great? I thought you'd like that. It's a 1. And then a plus, and then R.
Yeah, that's
R
one
is
cool
your
thing.
R is your rate of
Which
increase.
is 6%.
Right? In this case, it increases by 6% each year. So it's a rate of increase, right? And you always write it as a decimal. Always write it as a decimal. So you would have to change that to 0.06, right?
Yep.
All right. And your T is a number of years. T is in years. Okay, it's not in seconds, minutes, hours, days, months, weeks,
What about the, it's the
decades.
same for the
It's
exponential
years.
decay?
And for decay, it's exactly the same thing.
What
That-
about compound interest?
And then compound interest, notice it looks scary, but really, actually, compound interest is the same as this,
It does.
with one little exception. The R is your annual rate, just like here, right?
Divided.
That's an annual rate. But when you compound money,
Yeah.
okay, compound money, the N is the number of times it's compounded in a year. So if I said compounded annually, well, it would be the rate over 1 because it would be 1 time a year, right? So this is compounded annually, basically.
Wait.
This has, the N is a 1 here and the N is a 1 here. So I don't need to write it because R over 1 is the same as R. 1 times T is the same as T, right? But here, in compound interest, sometimes you will compound your interest quarterly.
But you will never compound your interest quarterly or anything like that?
Not with this, no. Because this isn't really interest. This is more,
So is the A still amount and or is the A final amount and
yeah.
the P
So the A is your final amount and your P, when you talk money in particular, they usually use P for principal, the word principal. And principal stands for the amount of money you start with, okay? This is not principal, this is actually the value of a painting,
And then
right? So we're just going to use this. But principal would be an actual monetary amount that you're investing, right?
what's
And
NT?
you
What's
could
A?
you could technically use this one as for this example too. A is your final amount after the years.
What's NT though?
N is the number of times
It
it's
looks like it's
compounded
not
per
in
year
this
times the number of years. That make sense? So if it was once a year, it'd be just the number. If it would be 1 times T, right? But if it was 4 times a year, it would be 4 times t, right? Makes sense, right? So it's not, it's almost identical to this. It's just that one little end thing. Oops,
No, don't destroy the smiley face.
He was so happy.
You destroyed it.
Rest in pieces.
you were enjoying it. Okay, so
We
let's look at this. I'm running out of time here, so we're going to kind of go fast. But I think you understand it. So it says the original amount of the painting is $1,200, and the value increases by 6% each year. And then this is my first step. It says write the exponential growth function. That means an equation, right? To model this situation. So I'm going to use this formula. So I'm going to write my formula first. Y is equal to A parenthesis 1 plus R to the T. And then I'm going to start plugging things in. So everybody agrees that 1,200 is A, right? That's your initial amount. So I'm going to put 1,200 parenthesis 1 plus
6%.
yeah, so how do I write that as a decimal?
0.06.
0.06, right? And then raised to the t power.
15.
What's 12 times
It'd be
Oh, wait.
15.
But wait. They first said write an exponential growth function to model this situation. And they haven't said 15 years yet. I'm writing a function. And then I could figure it out for any number of years, right? I could change t to 15, t to 30, t to 50. You see what I'm saying?
Yes.
So this is my function that I'll be using, but I'm not quite done. I've got to combine these. So technically, this would be it. Y is equal to 1,200, parenthesis 1.06, parenthesis to the t. So that is my function.
No, wouldn't it be to the 15?
No, I just said, this is the function to model the situation. I haven't gotten to the 15 years yet.
Oh, okay.
Because I could use this for any number of years. Do you know what I mean? This is useful now for any number of years. Now they're saying the second part, it says then, that's number 2, then find the value of the painting after 15 years.
Okay.
So now, to find the value, so this is number 2, right? To find the value after 15 years, I rewrite it, and in place of t, I put 15, right? 1,200 parenthesis 1.06 parenthesis to the 15th power. Now, you can't use a real simple calculator, you know? It does not work. It does not work to use the Walmart special, right? You know, for $1.99. They don't work. Because they don't, I mean, they do. You could do it, right? I would have to write
It would be
1,200 times 1.06
15.
times 1.06 times 1.06 times 1.06 times 1.06, right? So you could use it. It would just take a while. So if you use these other calculators that are a little fancier, right? They have a button.
So fancy.
Some of the buttons. Well, let's see. This button says this. It has this button on it. X to. It has like a little solid square. Another one that I have. It's more typical. You'll see this. You'll see.
Oh yeah, I saw that.
I think Y to the X, or X to the Y, or
Yeah,
something
I
like
have
that.
that one on my iPhone.
Right? So both of these are the same button, right, on these calculators. It just depends on which calculator you have and which way they did it. But basically what you do is you would type in, turn this on, you type 1,200. So I'm doing this. I'm doing 1,200, and then I'm hitting times. Did I hit times yet? Times. And then I'm going to hit 1.06. So times 1.06, right? Did I do that? 1.06. And then I'm going to hit one of these buttons. So we'll just say time, oh, not even times. You just hit Y to the X, or X to the square. Does that make sense? That's a button, right? You hit
What?
that. Because the 1.06 is your Y, and your exponent is going to be the next number you press. The next number is I'm going to press 15. Right? Does that make sense? You see that? And so now I'm going to hit 15, And then I'm going to hit equals. That didn't work. Oh, I didn't hit the button. Oh, great. That's what happens when I'm talking.
Good job, Gary.
Good job, Gary. This is a great video. Jeez Louise. Okay,
GG,
1.06.
Gary.
And then I hit, where is that button? Oh yeah, there it is. And then I hit 15. Equals, aha.
Got it? Yeah.
Here we go. Ready? It's this.
Okay.
It's 2875. So in 15 years, that painting that was $1,200 more than doubled. More than doubled in value.
In 15 years?
In 15
That's
years.
That's not too good.
Oh, that's not so bad. But
Well,
there are better
if it's raising
investments.
6% every year, that's really good exponential growth. But
Yeah.
nonetheless, it's not the best.
But
It's
still. So
usually only zero.
it more than doubled. So let's say you had an art collection that was worth $100,000. It's going to be worth $250,000, right?
Is this real life?
In 15 years. Now that's not so bad. When you start dealing with a larger chunk in the beginning, a larger original amount, it becomes a little more significant. Now, I'm running out of time, so I'm going to just say one other thing. So, yes, question.
So, you always say that back in when you were a kid, that that banks would give interest of like 5%.
For a savings
How come
account,
they
yeah.
only give
0.7%,
less than 1%?
yeah.
Because the stock market crash.
Yeah, I don't know the full answer. I mean, I don't know the answer.
A recession.
I mean, my sense is they realized that they were being too generous. But, you know what I mean? But I think there's more to it than that. I think the economy is different than it was back then, and everything. So I know it's time. So the homework you're going to have tonight is going to be like this, okay? Now, what I'm going to suggest is you don't have to do the compound interest ones yet, unless you want to. All I'm going to have you do is exponential growth, exponential decay, right? And then we'll deal with that tomorrow maybe, okay? And sort of
For the weekend, yeah.
all right. I'm also going to give you a short little quiz. A short little quiz on exponents in general, exponent rules. Oh no, I gave you that already, right? You did it in the take home. Never mind, I don't have to do that. That's awesome. Yes.
Wasn't that a week
Okay.
ago?
Yeah, but I haven't graded it yet. I will. I'll do it this week.
Have you lost them?
I gave them to you. Where'd you put them? All right.
He gave them to me, and I